Howdy. In previous videos, we've talked about how to find the limit as x approaches a number. Now what I want to do is I want to find the limit as x approaches infinity. Now I love limits to infinity because these, once you get good at it, should take you less than 1 second to instantly be able to figure out the answer. So it's pretty cool. Now some of them will get tricky and we'll get into that in this video, but let's talk about in general how to find the limit to infinity. Okay? Now, whenever doing limits to infinity, all I need you to do is look. I need you to look at the highest power in the numerator and the highest power in the denominator. And you're going to get one of three things. One of three categories is what I broke it down into. And our first category is a top-heavy function. Okay. Actually, let's go ahead, just jot this down. Real quick, pause the video, jot this down so we can talk about it. Okay. So the first type that you're going to get is a top-heavy function. And an example of a top-heavy function is when the highest power on top is the exact same as it's not the same, is bigger than the highest power on bottom. And if the highest power on top is bigger than the highest power on bottom, your final answer will either be positive or negative infinity. This is the only one that takes a little bit of work, and I'll show you how to do that when we get there. The next type of function is a bottom-heavy function, and what that means is that the highest power on bottom is bigger than the highest power on top. And if this is the case 100,000% of the time, it's going to be 0. Period. So that's kind of nice. And if it's the same power on top and bottom, if the highest powers are the same, then all you do is you simply take the leading coefficients, the numbers in front of basically your leading coefficients, and what that's going to be in this case, it would be 2/3. Okay, so let's run through a couple of examples. Let's take a look at A. Notice that in this problem the highest power on top is the same as the highest power on bottom, so because of that you just take the coefficients 1/4. For number 2, okay, or part B, notice how the highest power on bottom is bigger than the highest power on top. So because of that, instantly I know that it's 0. Let's take a look at C. Okay, so for C, notice that the highest power on top, which is a 6, is bigger than the highest power on bottom. So what you're going to do in this case, I know it's going to be positive or negative infinity. I just need to figure out, well, is it positive or negative? So what I do is I only take the leading terms. That's all that I care about when it comes to these problems. And so leading term on top is a negative 4x to the 6th. Leading term on bottom is a 2x cubed, and I simplify it. I simplify it to get negative 2x cubed, and at this point, that's when you plug in your infinity. And when I plug infinity into here, this is negative 2 times infinity cubed, which is, well, just negative infinity. You just got to be careful with these, because had this been a negative infinity, and negative times a negative would be positive, and so forth. There's lots of different scenarios, but when it comes to these problems, all I need you to do, leading term on top, divided by leading term on bottom, and plug in your infinity. Cool? So this deals with our basic cases. That's kind of nice, but let's get into a couple of complicated cases, all right? Let's deal with that. So let's do a couple of problems like this. Okay. So let's talk about limits to infinity when square roots are involved. Now, going back to my pre-calc class, okay, going back to pre-calc for a sec. What is the square root of x squared equal to? Okay, the square root of x squared is not just x. It's the absolute value of x, okay? The reason it's the absolute value of x is because you can't output a negative number. You can't take the square root of something and output a negative number, so it's always the absolute value. Now, let's remind ourselves once again what the absolute value of x looks like. We know what it looks like. It's a v, right? It's like that. And once again, if I extended this line, this would be the graph y equals positive x. And if I extended this line, this would be the graph y equals negative x. And why this is important. This is absolutely vital. Once again, I'm only looking at the leading term, but if I take the limit as x approaches positive infinity of the square root of x squared over x, notice that because this is absolute value of x, and I'm going to a positive infinity, out at positive infinity, That's on the line y equals positive x. So this would be a positive x over x, and then you just go from there. But if I have the limit as x approaches negative infinity of the square root of x squared over x, square root of x squared is absolute value. And the absolute value, okay, if I go to negative infinity, I'm technically on the line y equals negative x. So because I'm on the line y equals negative x, this is going to be a negative x over x. And you go from there. Very, very tricky. Make sure that you are aware of that whenever dealing with these limits with square roots involved. So if I took a look at this example, the limit as x approaches infinity of all of this. Once again, I'm only looking at the leading term on top. Square root of 7x squared over leading term on bottom 3x. Now because this is going to a positive infinity, when I take the square root of that x squared, this is going to be a positive square root of 7 times x over 3x. Had I been going to negative infinity, I would have made this negative. Now I see that it's same power on top, same power on bottom, so you just take your leading coefficients. Your final answer is a positive square root of 7 over 3. Just be aware that if you're going to a negative infinity, you would make this negative square root of 7 and then over 3. Okay? Now the last type of problem that you're going to see with limits to infinity is actually the one problem I missed. It actually still haunts me to this day. Got a 96 on my first test. I missed one question. This is the one question. So hey, if you're able to get this one, then you're ahead of where I was when it came to limits to infinity. Than I was my freshman year. Okay, so with the square roots, I have the limit as x approaches infinity of the square root of 49x squared minus 5x plus 1 minus 7x. Okay, what you're going to need to do, what you're going to do 110% of the time, is multiply by the conjugate. Anytime you have a limit with a square root, plus or minus with anything else, you're going to multiply by the conjugate. Now, what is that? If I have like some random a plus b, the conjugate of a plus b is a minus b. Basically just change the sign. And I love multiplying by the conjugate because a plus b times a minus b, if I was to fully FOIL this out and simplify, it's simply just the first term squared minus the second term squared. So when I multiply by the conjugate, this will be the square root of 49x squared minus 5x plus 1 plus 7x. You just change the sign of the middle term. Now, you don't want to just multiply by like this and be done, because you're not done. You got to divide it by the same thing, the square root of 49x squared minus 5x plus 1 plus 7x. The reason you need to do it on both top and bottom is because we're going to multiply by 1. I don't want to change the value of the function. I'm just manipulating it and strategically multiplying by 1 in order to help us solve this problem. Anyways, as I keep on going, this will be the limit as x approaches infinity. Remember to always write your limits until you get to your final answer. Now when you multiply across the top, the conjugate is just the first term squared minus the second term squared. And this right here is my first term. This right here is like my a. This right here is like my b. And so whenever I square the first term, you just lift the square root. And so lifting that square root, that's going to be 49x squared minus 5x plus 1 minus, and then b squared, squaring this guy, 7x, that whole thing squared, is going to be 49x squared. Now on bottom, leave alone. On bottom, you still have the square root of 49x squared minus 5x plus 1 plus 7x. Okay, so let's see what I can do here. 49x squared minus 49x squared, that's cool. That cancels. And so what I have is I have the limit as x approaches infinity of negative 5x plus 1 over the square root of 49x squared minus 5x plus 1 plus 7x. Okay. Now limits to infinity. All I care about is the leading term. Everything else is irrelevant. So the highest power, my leading term overall on top, is a negative 5x. On bottom, the leading term here, I have a square root of 49x squared, as well as this 7x. They have the same powers, okay? Because the square root of x squared, that has a power still of 1. So I'm going to take both into account. And I need to be aware, am I going to positive or negative infinity? And I see that I'm going to positive infinity. Because I'm going to positive infinity, when I take the square root of this x squared, that's positive. Had it been negative infinity, you'd have made it a negative. So this is negative 5x over. This is going to be a positive. The square root of 49x squared is 7x plus 7x, which negative 5x over 7 plus 7 is going to be negative 5x over 14x. Same power on top and bottom. Your final answer is negative 5 over 14.